men. And as usual, I use the term ever so loosely. If you watch the Bad Enough 9 video, this is the piston that was featured in that video. And this is the front, and this is the rear. I think the pieces that broke off of this piston, of which there's a lot, you could see, you know, chunks of piston ring embedded in the top of the piston here, little bits and pieces rammed in there, broken piston ring. I think some of these got bounced into the intake manifold where they got sucked into the rear cylinder and pockmarked the top of this piston. But I've been looking at this and I've been trying to figure out what went wrong. Where did the, what predicated this failure? The piston is scuffed all the way around. We're going to talk about this in a second. Piston is scuffed all the way around. The rear one was, I think, on its way, but not nearly as bad as the front one. The rear is pretty much down the middle, which is what you would expect on the front and the back. If a rod was bent and the piston was going up and down a little cockamamie, you'd expect the wear to be sideways a little bit, okay? Not going to talk too much about this one. I'm going to talk about this one. Scuffed all the way around. I happen to know that these were V-twin cylinders and pistons, you know, the reproduction ones. I'm not prone to immediately suspect a bad cylinder and piston and improper fit. The fact that it's scuffed all the way around does kind of make me think that maybe it was fit a little tight. I don't know. But it's concerning. Broken pieces everywhere on this thing. You could see all of this melted out of there. The owner of this engine told me when he drained the oil out of the oil tank, it had a heavy smell of gasoline. He thought there was a lot of gas in the oil. Could it have been that this thing, the carb flooded out, ran into the cylinders and, leaked down between the rings and the piston and, had a blowtorch effect while it was running? I don't know. Could this be because, the carb was too lean or too rich and it just burned it? Could it be because this was all fitted too tight and it melted it? I just don't know. The connecting rod, which I'll show you in a little bit, was heavily overheated at the piston pin end. And I started looking at the damage in here. See if I get the light a little bit better, maybe. Okay, that is perhaps a little better angle for you to see what's going on in there. But for this to be broken out in here, the piston pin would have had to been bouncing up and down like this. Well, how could that be? The piston is a pretty snug fit in the cylinder, especially if, as I might suspect, that it was fit a little tight in there. So the piston's not going to be able to do any rocking back and forth. Not much to any great degree. How could this get like this? And the rod was severely overheated. It was severely discolored. Anyway, it led me to suspect that perhaps the connecting rod was bent. And that's what we're going to look at right now. This is the rod that was attached to this piston. And you can see I have it marked bent. I was originally planning on reusing this rod. Actually, the rod set. Here's the other one. But, there was some weirdness going on with the way this piston had failed, and I was just not comfortable. So The question arises is, how do you check this for being bent? It's a difficult thing to work with because, you know, this is wider than this, so you can't just lay it on a surface plate and make sure that it's flat. You don't know for sure that the sides are perpendicular to the bearing race. Maybe they are, maybe they aren't. And even if they're perpendicular to this bearing race, you don't know that they're parallel or perpendicular to this bushing. I've got a surface plate, and there just isn't a good way to do this that I have found. You know, so in all is lost, what do? You confer with the Harley manual. Well, the Harley manual tells you to get one of their fixturing plates, bolt it to the top of the crankcase, rotate the engine up and down, and put a piece of thin paper under both sides of the pin, and with the pin contacting the fixturing plate, pull the paper, make sure it's got equal force pulling it out. Well, that's just great. The only problem with that is by then your engine is all together. What if you don't want to put a bent rod in there? Oh, and Harley further states that you could straighten a bent rod by prying on it. Let me show you what I have for doing that. I have this, which is actually very close to the Harley tool, and I've actually done that on some engines that I've rebuilt. I'm not going to say it's a routine thing that I check, but if I needed to, I could. Anyway, I have some flat aluminum blocks that I use in place of the Harley fixturing gauge, and this is a broken breaker bar that I machine the end down on to be a press fit into a standard Harley piston pin. So Harley tells you to, you know, get your rod in the engine, put in something approximately the same diameter as the bushing, and just, you know, push and pull and twist on it till you get it where you want it. But like I say, that's not necessarily something you want to find out after you've put the engine together, because what if you don't want to put a bent rod in? You need to find out beforehand. So obviously with this kind of a failure, you definitely don't want it happening again. And I decided I had to figure out a way to check these rods before I put the engine together. So this is what I came up with. In the lathe chuck, I have chucked up in there an expanding mandrel. The mandrel is expanded to the inside race of the connecting rod. I got a dial indicator on a mag base stuck to the cross slide over here. So I got a pin. This is a nothing more than a piece of steel bar I machined to the diameter of a wrist pin. I could use a wrist pin, but I opted to use something longer to exaggerate the error, to give me a better indication of what's bent or what's not bent. The longer the rod is, the greater the error is out at the end. So if we swing the rod and the pin by the dial indicator, it will deflect the dial indicator. And right now, I just have it adjusted so that the farthest deflection is 0. Okay, so there you go. And then of course we back it off and it returns to its original position. Okay, so that's 0. So let's compare it to the other side. And I'm just going to crank the cross slide over a couple inches. And look at this. The pin barely deflects the indicator. So these things are out of whack with one another by a little more than 100,000ths of an inch. This side moves the dial indicator more, so that means that this side is closer to the indicator, which means the rod has a dog leg in it. And in order to keep track of that dog leg, I'm just going to draw it on here. the rod must be bent in this kind of direction. Remember, the pin goes across here, and it's closer to the indicator on this end than it is on this end. So yeah, that rod must be bent, and it must be bent kind of a lot. Barely moves over there. Crank it over to the other side, and it moves per near 100,000ths of an inch. Well, you say, maybe my pin is bent. Well, okay, let's flip the pin around. Same result pretty much exactly. Moves 100,000ths on that end. Barely moves on this end. So the pin is not bent. Well, maybe the mandrel is bent. So let's undo the rod and flip it around in the mandrel and see if the results stay with the mandrel, which if the mandrel was bent and the rod was straight, the results would not change. However, if I flip the rod around and the mandrel is straight and the rod is bent, now my results are going to be opposite. It's going to move 100,000ths of an inch when the indicator passes this end and barely moves when it passes that end. And I'm trying not to bump the camera, trying not to bump the indicator. Okay, so the rod is flipped. Okay, so if the mandrel is straight, this end should now move that 100,000ths of an inch. And look at that, it does just about exactly. And this end should barely move at all. And it barely moves at all. I think that conclusively proves that this rod is bent. Of course, you saw that I had it marked bent already, so you know I've already checked this to see if it works, and it does. I haven't checked the female rod though, so let's throw that in there and see what it does. Okay, I got the male rod chucked up on the mandrel, same pin. I turned the face of the indicator a little bit more towards you, but otherwise haven't moved it. So let's see what happens over here. I'm going to re-zero this. Okay, re-zeroed. Okay, so there we go, that's 0. That's the farthest point of travel. Let's move the cross slide over to the other side of the pin. And this one is bent too. Not nearly as bad as the other one, but bent. Since these rods have been replaced already, and this one looks like it's maybe bent about 5,000ths of an inch. Yeah, maybe 5. I'm going to grab that straightening bar and see if I could straighten this. Alright, so we're going to try to straighten this. See if I can do it or not. Okay, we're about +7. So this side is higher than that side. So that means this rod, greatly exaggerated of course, must be bent like this. like this. So, get my indicator out of the way, take the test fitting pin out, put in the bending tool, and I now have to apply force directly in the direction of the mag base that's holding the camera. So hopefully nothing slips or breaks. Just leaning on it a little. I think you can see the rod flex a little. Okay, we'll see what happens. If I bent the rod at all, the zero, of course, should have moved. And it did move. Whoa, way more than I thought it would move. So let's re-zero. So I bent it a lot doing that. Okay, that's pretty much re-zeroed. Yeah, it bent it. I guess no surprise there. So let's recalculate here. I'm re-zeroed over here. And I'm not quite getting back to zero. I'm about 6,000 short. So that means I have to move this side the other direction about 3 thou. Interesting. So instead of leaning on it, I'm going to pull on it a little bit. I'm going to try to pull on it a little less. Wow. And I moved it again quite a bit more than I would have thought I was moving it. Wow. So a re-zero. And we'll go back over here. Wow. So this side is high by 15 thousandths. So I've got to go back in the original direction, 7 thousandths of an inch. Interesting. All right, I've been jimmying the rod back and forth. And that's pretty much zero on that end. We'll go back to the other side. Ooh. And that's within half a thou. Yeah, I'm pretty sure that's as good as I could get this. So yes, you could tell the rod is bent. There may be other ways of doing this, but this is the way I stumbled across. And yes, you can straighten a rod out. Would I be scared to use this rod again? No, not at all. Now the other rod that was out by 100 thou and had been severely overheated, yeah, that rod I would be concerned about. So yes, you can tell if they're bent and you can straighten them. Is this the only way? Probably not. Is this the best way? Probably not. But it's the way I found that, you know, works with the material and the equipment I have. So if I need to do it, I can. Anyway, back into the clean shop and a couple more items of discussion, and then we'll be done. All right. We were out in the dirty shop bending connecting rods and checking to see if they were bent. And we're talking about bending in, you know, this direction, back and forth this way. And there's other ways they could be bent too. They could have a twist to them, you know, a twist. We're going to talk about that in a minute and a way to check that. But I want to clarify something about the measurements I was getting. I had been talking about thousandths of an inch as far as how many thousandths of an inch this pin moved one way or the other, and using that as an indication of how bent the rod is. We're not really talking about thousandths of an inch. Well, we are and we aren't. Those are just numbers, and essentially they mean nothing. What we're really talking about is angles. So at this end of the rod, the big end, imagine a line going through the middle of it, exactly perpendicular to the rod. And imagine the same thing at this end, a line going through this exactly perpendicular to the rod. This line and this line are supposed to be parallel, so there's going to be no variation in there. Well, what we're really talking about is the angle of these things. And let me try to draw what I'm talking about and show you what I mean. Okay, what we're really talking about is the angle variation. Here's, you know, the connecting rod. Here's that line perpendicular to the center of the rod. And here's this other line perpendicular to the big end of the rod. And, you know, we have these gauges. Let's just say this one is plus 10, and let's just say this one is minus 10, okay? So you really have a triangle. And the triangle is, you know, these points right here, okay? This triangle. And if the rod was perfectly square, this angle over here is going to be equal to this angle over here, and the lines will be parallel. But if we bend the rod, this line right here changes, and it will be at an angle compared to what it started out at. And it'll be an angle, I'm greatly exaggerated, of course, something like this. Well, now these two angles, here and here, are no longer going to be the same. And this parallel axis over here is now not parallel anymore. Now, if I had paid attention and had any aptitude back in high school, trigonometry could tell you what this angle is. If you know this length from here to here, and this length from here to here, and any one of these angles, or any two, I forget the formulas exactly, but a mathematician could figure it out. You're actually calculating a degree of bent. So really, like I say, it's not distances, it's angles that we're measuring. We're just not doing the calculation to figure out what the angle is. But anyway, point being is, if this angle is 2 degrees down in here, the extended angle is also 2 degrees. So, you know, you build in 2 degrees of angle, and, you know, this is how much the rod has been. It really is measured in degrees, not in distance. But the average Joe can't calculate the angles. And for a guy who's trying to straighten out a rod, we really don't care. All we care about is that these numbers are the same or very, very close to the same, because if they're the same, then you know these angles, these inside angles are going to be the same, and that the axes of the rod, the big end and the small end, are going to be parallel and the same. But anyway, that's this kind of twist. I just wanted to, you know, let y'all know that, yes, I was giving you a number in distance, you know, the plus 10, 100 thousandths, whatever. that really isn't what we're talking about. What we're really talking about is this angle and the relationship of these angles to, you know, the shaft of the crank pin, you know, the center axis of the crank pin on the big end compared to the axis of the piston pin on the small end. That's what we're talking about on that. Now, an old buddy of mine I've known since kindergarten years, so it's going to be a long time. We're both 70, you know, or thereabouts. He's a really smart guy. He is a engineer, and he says he watches the videos. So anyway, you know who you are. I'm not going to call you out by name, but you know, you could apply your higher mathematics that you engineers use and you know, calculate this. I know you can't calculate it because I haven't given you, you need some distances, exact distances to do the calculation. But anyway, a guy who's good with math, knows a little trigonometry, and actually takes measurements of these lengths, can calculate these angles and say, oh yeah, your rod is bent in, you know, 3 degrees off parallel, and that's the number that actually means something. You know, this plus 50 thousandths or minus, those numbers mean nothing. It's the angle that we're really talking about. The other way a rod could be bent is it could have a twist in it. All right, so I have a pin that I machined to be, you know, round and parallel, and this is the pin I was using out on the lathe when checking for bend in this direction. So we're now checking for twist. So I've got this supported on 1, 2, 3 blocks, so these should be parallel, and these are 1, 2, 3 blocks, and they should be parallel. And yeah, I know in the world of precision machining, you know, this might not be the most precise. I mean, these are probably Amazon 1, 2, 3 blocks, although I did pick a bunch up at some estate sales. But you know, there could be a little error in there, but the point being is that this should sit flat on here and this should sit flat on here. If there was a twist in the rod, one side or the other on these pins won't be touching the blocks. So a 1.5 thou feeler gauge does not fit. A 1.5 thou feeler gauge slides right under here. So we'll check the back. Okay, the feeler gauge does not go in there. And the feeler gauge does not go in here. So this rod has a very, very slight twist in it. Well, 1/1000th. And once again, the number doesn't matter. We're probably talking degrees would be the correct unit of measurement, but that's not conveniently measurable. But maybe it is. I'm going to try something in a minute. And you might be able to rock this a little bit. And indeed, I don't know if you can hear it on camera or not, it rocks a little bit. I could hear it clicking back and forth. Interesting. Let me get my another measuring device. I'm going to try one other thing. Okay, like I say, we're talking about bends. We're really talking about angles, not distances. So I've got my digital angle indicator on my surface plate zeroed out, and I'm going to put it on the top of this pin, and we'll see what this pin reads. I'd like to be able to stick it on with the magnets that are on the bottom of this, but some idiot, me, made this out of stainless steel, so the magnets won't stick. So let's see if this is 0. It should be 0. Okay, 0. So that is parallel to the table, and there's no angular deflection at all. Okay, so I've got my angle indicator sitting on the shaft that goes through the piston pin, and it's kind of been hoovering. Yeah, there we go. See, right now it's 0.15. You know, this isn't the most precise thing, but that's what I would expect. So yes, you can measure the angular shift from one end to the other. So I've demonstrated in theory you can measure the angular misalignment between the both, between both ends to see if it's got a twist in it. This rod was bent quite a bit. I guess it could probably be straightened. I don't believe these are heat treated. But I don't think I'm going to ever use this rod again. Anyway, that's, this is just kind of a gee whiz thing. But anyway, you got to be concerned about the twist in the rod besides the bend in the rod. Anyway, I'm going to wrap this up. The whole purpose of this gyration was to see if a rod was bent and try to make a determination as to whether or not a bent rod could have been the cause of this failure. And I'm inconclusive on all this. But this is the rod, and it was installed in this piston, and I've got a pin in it. And you could see, I could swing it in this direction because the piston pin hole is so wallowed out. The other hole, not nearly so much. I can't, there's no play on this side. There's a lot of play on this side. So could the rod have been bent a little bit? Could it have been putting a side load on the piston pin and, kind of forcing the piston to wobble? And, once it starts to go, I think it'd progress kind of rapidly, I would suppose. This thing had to have making a lot of noise, I would think. I mean, look how much the rod bangs up and down inside there. Comments, please. If anybody else has seen something like this, I'd like to know. When I try to straighten the rod out, and that's as close to straight, that's as far as it'll allow me to go, it looks like there's a little bit of an angle in there. Of course, the piston pin holes are so jacked up now. Does that prove anything or not? I don't know if it does. But yeah, this rod definitely, there's an angle between the rod and the piston. This has got a little cant to it. It certainly looks like. Anyway, it's time to wrap up this show and tell. The whole purpose of these gyrations was to, number one, try to determine if the rod is bent. And yes, it is bent. You'll notice the unevenness in the piston pin boss wear. I could tilt it pretty far to my left, not so much to my right. So if this rod was bent a little bit in the beginning, could that bend have caused premature wear on the piston pin boss? Maybe, or is this just a result of, the other damage? If anybody else has any comments, I'd certainly like to hear them. If anybody else has had experience with similar type damage, I'd certainly like to hear about it. But anyway, I thought I'd just throw this all out there for you to take a look at, and I'm going to call it a show and tell, because really, that's all it is. There's no revelations here. I was able to determine the rod was bent a little bit. How much that had to do with, the rest of this failure beats the hell out of me. You've got the melted piston and broken rings in through here. You got broken rings on the other side. Could a bent connecting rod cause that? Or did this damage, binding up cause the connecting rod to bend? And then you've got this big broken chunks out of the piston pin boss. Which came first, the chicken or the egg? I don't know. And with that, I am out of here. Y'all take it easy. Have a nice rest of your day. Thanks for watching. Bye. Men, if you like this channel and this content, the single most important thing you could do to help grow this channel is to hit the subscribe button. I also have new design coffee cups and stickers available. I like the old coffee cups, but I like these new ones even more. Links are included in the description down below. And for those of you who really want to go the extra mile, You could join me on Patreon. Link is also included in the description down below. And to all of you who have watched these videos, I'd like to say thank you. Thank you very much. I really, really do appreciate it. We'll see you next time. Bye.